Alright, hi guys, ready for video number 2. For part A, we used Desmos to graph, and so we're just going to provide a sketch on our notes. Along the horizontal axis, we have price, and our intercepts went out to 10, so I'm going to go by 2s. 2, 4, 6, 8, 10. And then vertically, we scaled all the way up to 20,000. So this was money because it was both the revenue and expense. So I'm going to go 5, 10, 15, and $20,000. Okay. Let's start with the line first for expense. It had a y-intercept of 10,000. And then an x-intercept of 10. And we found, or can find, both of those from that Desmos graph. If you just click, it should show up with those two. Let me, I put in a really rough line. This is our expense. And then the parabola passed through the origin. And then it came up to some height. And then it came back down again. So the where it crossed was like 8.5. Okay, so I know halfway is 9, so I went like only a quarter of the way in from here. And then the vertex was around like 4.25, and then it was like 18,000 something. So I'm just really rough ballpark. Some point up there would be about where the vertex is. So from there you can curve it. And this is the revenue. Let's analyze this graph a little bit. When we graphed expense and revenue before, we looked at where profit would be. And so profit occurs when you have revenue that's more than your expenses, or you're bringing in more money than what you're spending. So on the graph, where that would happen is in this middle section, okay, the region that's kind of bounded, because this is where you have revenue higher than what the expenses are. So inside this space is the profit. Okay. And it's the same as before, where the distance or the gap between the two lines is going to be the revenue. Okay. To the left here is a loss, and that's because we have expenses more than revenue. And then the same thing on this side, we would have another loss because expenses are more than the revenue. So, what do these 2 points mean then? Okay, the 2 points where revenue and expense intersect mean the same thing that they did before when revenue equaled expense and meant break even. So we would label, and this is unique because there's 2 break-even points now. We would have 2 break-even values. So circle the intersection of the 2 equations, and what do they represent? Okay, they are the break-even points. It's when expenses equals the revenue. Okay. So we can find those approximations from our graph using Desmos, but we're going to also find it algebraically. So I need another pen. Okay, so if we're finding the break-even points algebraically, it's when expense equals revenue. So our first step is to set up the equation. We are given the expense equation and then the revenue equation, so we can set those 2 calculations equal to each other. Okay, expense is negative 1,000 P plus 10,000, and then it will equal the revenue calculation, negative 1,000 P squared plus 8,500 P. So I took the two calculations from before and set them equal to each other. And that's because we're finding break even where expense equals revenue. Step 1 is done. We'll call that step 1. Step 2 is to get the equation equal to 0. We want to set it up to be able to use the quadratic formula. So we have this squared term and a linear term, and then on this side we have a linear term and a constant. Okay? We can move whichever two terms over we want. I'm going to choose to move these two terms over to the right hand side. So let's start with the negative 1000p. If we're going to move that to the other side, we're going to add 1000p to both sides. And notice where I placed it. I specifically placed it right below its like term. Okay. And so when I do that, I'll get 10,000 equals negative 1000p squared plus 9500p. Okay. We still need to get the equation equal to 0, so we're going to subtract 10,000. And neither one of these are like terms to 10,000, so I just stick it on the end and underneath an empty space. So then I've got 0 equals negative 1000p squared plus 9500p minus 10,000. All right. Step 2 is done. Get the equation equal to 0. From here, it's like what we were doing yesterday. Step 3 is to identify A, B, and C. So from the equation of a quadratic, we have ax squared plus bx plus c. So a is the coefficient of the quadratic term, negative 1000. B is the coefficient of the linear term, 9500. And then c is negative 10,000. Okay. All right. Step 4 is to use the quadratic formula. Okay, the quadratic formula allows us to solve for the price or the prices that would get this equation equal to 0. So the quadratic formula is the opposite of b, negative 9500 plus or minus the square root of b squared is 9500 squared minus 4 times negative 1000 times negative 10,000. And that becomes from minus 4ac. Then it's all over 2a, which is negative 1000. All right. Simplifying this, we're going to simplify inside the radical first, and then take that square root. Okay. So I'm going to set it up. Okay. If you take this inside, you'll get a big number, and then when you square root it, you'll get 5,678.908346. Okay. Some of you might be asking, do I have to write out all the decimals? And my answer is you should be as precise as you can because we're not done with the answer or the problem yet. When you round up an answer partway through a problem, your answer at the end will be a lot more further off than what you wanted it to be. So try and keep this as precise as you can. Okay. From here, we split it apart. We have negative 9500 plus 5678 point. I'm going to put ... but know that in my calculator I'm going to be putting in all those decimals. Divided by negative 2000. Or P equals negative 9500 plus, minus 5678 point, and then all the decimals over negative 2000. All right, you should get the answers of 1.41 and 7.09. So those are our break-even prices. Those are the prices that would yield the same expenses and revenue. So algebraically, or graphically, sorry, what we found was here, this number was like 1.41, and then this price 7.09. So my sketches were a little bit off, but we're finding the prices of the break-even. The idea is you set the revenue equal to expense, and then you solve using the quadratic formula, like what we did last time.